A very simple example of Azure machine learning. We are looking at a CSV file now. It has historical bike rental data from the year 2011 and 12. It has columns such as day, month, year, season, holiday, etc. And if you look at the column M, it has the number of rentals made on that specific day. So basically what we're going to do is use attributes such as day, month, year, season, holiday, etc. and predict number of rentals for a specific day. So the attributes such as day, month, year, season, holiday, etc. are called features. We will use those features to calculate the number of rentals, and in this case rental will be called as label. Okay, so let's see how we can do this using Azure machine learning. At the Azure portal screen now, the very first thing we need to do is create an Azure machine learning workspace. This workspace will help us manage code, compute resources, data stores, data sets, and other artifacts related to machine learning. In order to do that, we need to create a machine learning workspace. So if you look at the top left hand side corner, you can see a menu icon. You can click on it and click on create resource option, and once you're there you can type machine learning and press enter. The very first option here is for creating machine learning workspace. You can click on create and machine learning. That would bring up the machine learning workspace creation screen. So here we can give a resource group name, select existing. We don't have one, so I'm going to create a new resource group. I'm going to call it as machine learning bike rental and click OK, and give a workspace name. Let's call it as machine learning example 1. And I'm choosing East US2 as a region, storage account is new, key vault, all that default, and now review and create. Okay, and click on create button. Okay, so now Azure is creating a machine learning workspace for us. It's gonna take a few minutes, so I'll pause the recording. Awesome, now we have our machine learning workspace created. You can click on go to resource button. That will take us to machine learning example 1 workspace. If you look at the left hand side, we have different categories such as settings, monitoring, automation, support, and troubleshooting. Under manage your machine learning lifecycle section, we have a button, launch studio. This will help us to launch Azure Machine Learning Studio. This will help us to build, train, evaluate, and deploy machine learning models. So let's click on Launch Studio button. That will take us to Azure Machine Learning Studio. Here again on the left-hand side, we have 3 different categories: authoring tools, assets, and compute. Under authoring tools, we have notebooks where we can write Python code. Automated ML, we will use automated ML for the bike rental example. This will help us to train and find the best model based on the CSV data we provide without writing a single line of code. Then we have designer. Designer will help us to create pipelines using drag and drop option. Then we have assets. Under assets, we have datasets. That's where we will upload the CSV data. Then we have experiments. We'll go through that, pipelines, models, endpoints, etc. And then under manage section, we have compute, which we would use to create compute instances, compute clusters, etc. Okay, now let's click on automated ML option under authoring tools. That will take us to automated ML screen. Click on new automated ML run button. That will take us to create a new automated ML run page. The very first step we need to do here is upload the bike share rental CSV file. How do we do that? Click on create dataset button. We get 4 options from here, from local files, from data store, from web files, and from open datasets. Since we have the bike rental file on our local drive, click on from local files option. Name it as bike underscore rental. Click on next button, and we can upload the file by clicking on upload button, upload files option, choose daily bike share file, upload it, and then click on next button. So file is being parsed now, and in here choose only first file has headers. We don't need to skip any rows. Once that is done, click on next button again, and we can see all the columns. Make sure we have all listed in here, and then click on next button again. Okay, so here you can look at the details and verify we have the right file uploaded, and then click on create button. So now we have bike rental dataset created and available for use. So choose bike rental and click on next button. So now we are configuring the run. So give it a name, bike underscore rental 1. Target column. So this is the column we talked about earlier, the label, rentals, and then select a compute cluster. So we don't have a computer cluster now, so we'll have to create a new compute cluster. So you can choose or click on create a new compute button. That will take us to create compute cluster screen. So here we can choose an option. In order to do that, click on select from all options. Okay, let's go for DS11 underscore v2 option. You can select standard underscore DS11 underscore v2 option and click on next button. Name it as bike rental C1, and minimum number of nodes 0, maximum number of nodes, let's make it 2. Idle seconds before scale down is 1/800, let's make it 60, and click on create option. Takes few seconds to create the compute cluster. Awesome. So now we have the compute cluster created. Let's click on the next button. So we need to predict a numeric value, which is the number of rentals. We already have the regression option selected. Let's click on view additional configuration settings option now. So we have the primary metric option selected as normalized root mean squared error. We don't need to change that now. Under blocked algorithms, let's add all the algorithms except random forest and light GBM. So I'm gonna select all the others under blocked algorithm list. All right, so we just have two algorithms now, and let's also define the exit criteria. Now training job time 6 hours. Let's make it to 20 minutes. Is that, no. Let's make it 30 minutes, right? And under metric score threshold, let's make it 0.08. Okay, and I don't need to change validation and concurrency. Click on save, and let's look at view featureization. Featureization is already enabled, so we are good there. And let's click on finish. That will kick off automated ML run. Okay, run one not started. Okay, so it's running now. We can see that here. It's gonna run for around 30 minutes. I'll pause the recording and we'll restart once the model gets the run gets finished. Okay, now let's click on run one. This will take us to run one details screen. It has multiple tabs. Click on details tab. We can see a summary of run one as properties, best model summary. Under best model summary section, click on the algorithm name, voting and symbol. This will take us to the model tab, and it has a deploy option. Click on deploy button and name it as bike rental 1, and instead of AKS, let's choose ACI, Azure Container Instance, and click on deploy button. So what we're gonna do here is we're gonna deploy the model, and we'll have a REST endpoint created. Okay, so the deployment has been completed now. We have the REST endpoint URL available here. We can test it using the test tab, or we can test it using programming languages using C#, Python, or R. The code will be automatically generated. We can copy this code and execute it from a local computer, or we can use the notebooks option under Azure Machine Learning Studio. So let's try the test tab option first. let's say day to month to year 2023, and then yeah, that's good. So let's say test, and the prediction says there will be 335 rentals on Feb 2 of 2023. So we can do the same using Python code 2. Let's click on the consume tab, click on Python tab, copy the Python code, and then go to notebooks under authoring tab, create a new Python file. Let's name it as bike rental prediction. Okay, let's create it and paste the code snippet here, and let's run it. Okay, so we don't have a compute resource to run this, so let's create a compute resource for that. I think we'll do the same DS11 option. DS11 need to do that. Let's wait for the compute resource to be created, and once it is available, we can start running the Python code from here. Right, now we have the compute resource created. We should be able to run the Python script from here now. Before executing the script, let's change the day, month, and year values. Day is now 2, and month is 2 February, and year is 2023. All right, let's execute the script. We can use the green play button. Right, the script has been executed. The result is here: 335 rentals on Feb 2 2023. So we tested the exposed REST endpoint URL from the test tab as well as from the Python script. So this is the URL, and other applications should be able to consume this URL and predict bike rentals for a specific day.